Students, you might have noticed the similarities in substitution and elimination reactions. So let us discuss how substitution versus elimination reactions are going to compete with each other. Those substitution and elimination reactions lead to different product. In substitution, one nucleophile will replace the other, whereas in elimination, we are going to get a unsaturated product. There is always a competition between them because of the close resemblance in the mechanism. You can see Sn is very close to E1 mechanism, SN1 and E1 mechanism. You have noticed that carbonium ion is produced in it, and in SN2 and E2 it is a one-step process. Since substitution is more favorable energetically, it is the dominant reaction in the substitution versus elimination reaction. Means substitution reactions are more oftenly dominating. Elimination reaction occurs in the presence of beta hydrogen. So if we are having a substrate with no beta hydrogen, then substitution is going to be the product. We will get a substituted product. Whereas substitution requirement, it do not require a beta hydrogen. Now students, let us study the factors that are going to help us compare these two paths. The first one is structure of the substrate. Now students, crowding within the substrate prefers elimination. Now you can observe this second reaction in which the substrate is a crowded one. Means you can see this is a leaving group that is attached to a carbon which is attached with two methyl groups, whereas this carbon is attached to only one methyl group. Now students, crowding within a substrate is going to favor elimination over substitution because the approach of the nucleophile to the alpha carbon, remember in substitution, this nucleophile was attacking on the alpha carbon directly. But because of this crowding, it is going to hinder the reaction between the nucleophile and the carbon atom. Because of the crowding, this nucleophile is going to abstract a proton, and this bond will shift between these two carbon atoms, eliminating SCH3 whole twice and giving you elimination product. You can see the percentage, it is 61%, whereas substitution product is only 39%. However, the elimination is favored because the removal of beta hydrogen atom by the base from a tertiary or planar carbonium ion is easy. Whereas students, you can see in this example, the substrate is less crowded. So the approach of the nucleophile to the carbonium ion or the alpha carbon is very easy. Therefore, it is going to make a bond, a sigma bond directly with the alpha carbon, eliminating this product, which is the leaving group, SCH3 whole twice. Now you can see the percentage of the substitution product, which is 88%, because the approach of the nucleophile to the alpha carbon is easy. Elimination product is 12%. Now the structure of the substrate is going to help you out with the percentages of substitution and elimination products. Now students, let us discuss the nature of the base. When the electron pair donor is a strong base, means an incoming group is a strong base like hydroxyl ion or alkoxide ion, etc., the dominant reaction is E2, means elimination reaction following E2 mechanism. And SN2 reaction is a side reaction in this case. However, if the nucleophile is a weak base now, like X negative or RS negative, etc., the main reaction will be only SN2 and E2 will be a minor side reaction. Now students, you can see in the first reaction, I'm having a strong base. So strong base is going to give us E2, means the elimination product. This base is going to abstract the proton, shifting this bond between these two carbon atoms, eliminating X, giving you an elimination product. On the other hand, if we are having a weaker base, what is this? It is a carboxylate ion. CH3, C double bond O, O negative, and acetate ion. It is a weaker base. a weak base is directly going to attack on the alpha carbon, eliminating this X, giving you a substitution product. Now students, since it is a weak base, it is having a weak tendency to abstract a proton from the beta carbon atom. That is why it is going to prefer substitution as compared to elimination. Students, the third factor that we have to discuss is the nature of the leaving group. The role of leaving group in elimination reactions is similar to that in the substitution reactions that we have already discussed. In unimolecular reactions, it does not affect the mechanism because both the elimination and substitution products are decided by the carbonium ion. So in SN1 reaction and E1 reaction, the first step is the ionization process in which the carbocation formation is going to take place. The leaving group is going to depart before the arrival of the incoming nucleophile. That is why the nature of leaving group is not considered, or it does not affect the unimolecular reactions like SN1 and E1. However, in the bimolecular reactions, the nature of the product greatly depends upon the nature of the leaving group. Now students, consider this chemical equation. This is C18H37X. X is a leaving group over here. When it is going to react with tertiary potassium tertiary butoxide, it is going to give you an elimination product along with substitution. Now let us see at the percentage. If this X is equal to Br, means a bromine atom is attached over here, we know that bromine is a poor leaving group. Therefore, you can see the percentage of elimination reaction. Means the beta hydrogen will be abstracted, giving elimination in preference to substitution because this bromine is a poor leaving group. Now students, if X is tosylate group, which is an excellent leaving group, therefore you can see the percentage of substitution reaction. The incoming nucleophile is going to attack directly on the alpha carbon atom and it is going to substitute this OTS because OTS is a very good leaving group. So substitution product is 99% and elimination is only 1%. Now students, this is C18 and after that this is C16 because these two carbon atoms from C18 have been opened to show you the elimination and a pi bond formation between the two carbon atoms. Now students, the next factor that we have to discuss is the nature of the solvent. Elimination is favored more than substitution by decreasing solvent polarity. Means less polar the solvent is, elimination will be favored. So alcoholic potassium hydroxide affects elimination, while more polar aqueous potassium hydroxide, which is going to be more polar, it is used for substitution. E1 is favored by polar solvents like SN1. Now students, remember that in SN1 and E1 carbocation is formed. The first step is the ionization step, giving you a carbocation along with the leaving group. So these two ions, the cation and the anion, gets solvated by the polar solvent, hence stabilizing the two ions for the further reaction to take place. Whereas in non-polar solvents, the reaction will be E2 mechanism, means a bimolecular one-step reaction because there are no ions to be stabilized. So we use non-polar solvents. Students, the last factor that we have to discuss is the effect of temperature. An increase in temperature will always favor the elimination over substitution, because substitution reactions involve less reorganization of the bonds as compared to elimination. Now here we are having 2-bromopropane. When it is going to react with sodium hydroxide, it will give an elimination product, 1-propene, along with a substitution product. Now students, at 45 degrees centigrade, the elimination product is 53%, whereas substitution product is 47%. But by increasing the temperature at 100 degrees Celsius, you can see the elimination product is 64%, whereas substitution product is 36%. Now students, if you recall the reactions that we have already studied, In case of elimination reaction, two reactants are participating, giving three products, 1, 2 and 3. Whereas in all the substitution reactions, two molecules are participating, giving two products. Therefore, elimination is going to give you more products, the more number of products as compared to reactants. Therefore, it requires more reorganization of the bonds. So, increase in temperature is going to favor elimination products more, whereas such a requirement is not necessary in substitution reaction. There is less entropy or disturbance in the reaction medium. Students, I hope you have understood today's lecture. Try to apply the concepts and give detailed answer of the following questions. Thank you and Allah Hafiz.